Welcome on board the Airbus. The A320, A321 and A319 are narrow-bodied, twin-engined, short-medium-range aircraft. The A321 is an A320 with an extended fuselage and some minor changes, and the A319 is a shortened version. The A320 entered airline service in March 1988. The A321 in January 1994 and the A319 in 1996. They represent the new concept in air travel, designed to provide a maximum efficient use and to take the world's airlines profitably well into the 21st century. The Advanced Airbus product line incorporates a high degree of commonality between its family group members. This can give valuable savings in spares holding and training, as well as large benefits in operational flexibility. The A320 family incorporates advanced technology in every part of its design, as it incorporates an extensive use of new materials and processes. Fly-by-wire flight controls, besides giving full flight envelope protection, enable aircraft of radically different weights and sizes to be given identical handling characteristics. The A320 family is unique in offering a series of aircraft with virtually total commonality over a range of seating from 120 to 220. 4, 5 and 6 abreast seating possibilities allow lots of opportunity for meeting market requirements as they arise, each class offering a better standard than any competitor. Large overhead stowages have integrated handrails for added comfort and security. Digital cabin intercommunication data systems for ease of operation for flight and maintenance personnel. Forward and rear entry doors are the same on these three Airbuses. Middle exit doors have different arrangements due to fuselage lengths. The unique fuselage cross-section of the A320 family gives more efficient cargo holds. The containerized system uses LD3-based containers and is therefore fully compatible with existing ground service equipment and allows interline capability with wide-body aircraft. Full turnarounds can be very short with fully containerized cargo capacity. The A320 family flight deck offers an ergonomic layout of panels. The two-man crew concept uses side sticks with very precise movement. These leave the main instrument panel unobstructed. 6 display units are switchable, interchangeable, and integrated into the same system architecture. Both captain and first officer panels incorporate a primary flight display, which provides clear and accurate information on speed, altitude, attitude, and heading of the aircraft using an Air Data Inertial Reference System, ADIRS. Inboard, the navigation display provides the pilot with essential data on the aircraft position and course. These displays represent the Electronic Flight Instrument System. The main center panel presents the Electronic Centralized Aircraft Monitoring, or ECAM. The Engine Warning Display Unit shows the aircraft parameters. Below, the System Display Unit shows the system diagrams and status. The overhead panel push-button lights out philosophy is identical to all Airbus aircraft. The most frequently used functions are at the front. This forward zone is dedicated to system controls. The center row for engine-related systems, all arranged in a logical way. The aft zone is mainly for small maintenance panels, then emergency circuit breakers. Here are the other circuit breakers. Engines are normally operated from the center pedestal panel, master switches and thrust levers. The A320 family offers a choice of power plants, from CFM International 56 to International Aero Engines V2500, with different power ratings according to the aircraft model. These have a high power-weight ratio and are FADEC, full authority digital engine controlled, with low fuel burn and low emissions. The FADEC is a fully redundant engine control unit and an interface unit in relation with the aircraft systems. Let's have a look at some of these systems. The electrical power generation comprises 2 engine-driven AC generators, 1 APU AC generator, 1 emergency generator, 1 ground connector. The DC network is supplied via 3 transformer rectifiers or 2 batteries. Hydraulic power is provided by 3 independent systems: green, blue and yellow. A RAM air turbine may be automatically deployed to pressurize the blue system as a backup source. An advanced technology in electrical flight control systems. All wing and tailplane surfaces are electrically signaled and hydraulically actuated, whilst the rudder and pitch retain a mechanical signaling system. The flaps of the A321 are double slotted. Benefits of fly-by-wire technology are lower fuel burn, lower maintenance cost, flight envelope protection, load alleviation. The electrically controlled landing gear system comprises 2 main landing gear assemblies and a nose gear. The landing gear of the A321 is reinforced due to the weight increase. They are fitted with carbon brakes and radial tires, which have a longer life. Two types of APU, managed by an electronic control box, can be fitted on the A320 family. The GTCP 36300 from Garrett or the APS 3200 from Labinal and Sustrand. They are totally interchangeable, provided the electronic control box is changed. High-pressure air is supplied from different stages of the engine compressor, or the APU compressor, or ground connector. The air conditioning system provides temperature-controlled air for the cockpit and the forward and aft zones. The system philosophy is the same for each aircraft, but some components are changed because of the cabin volume difference. The A320 family wings take full advantage of all recent advances in aerodynamics, avionics and materials. Fuel is stored in the wings and a center tank. A digital fuel quantity indicating system is constantly monitoring. For the A320 and A319, the wing has an outer and inner cell. The A321, just a wing tank. The auto flight system is composed of 2 flight management and guidance computers, with a flight management part for navigation, performance optimization, navigation aids tuning, and a flight guidance part for autopilot commands, flight director and thrust commands. 2 flight augmentation computers provide rudder commands, flight envelope and speed computation. The FCU, Flight Control Unit, on the central glare shield provides the short-term interfaces between the crew and the FMGCs. 2 MCDUs, Multi-Purpose Control and Display Units, provide the long-term command interfaces. Line maintenance of the electronic systems is based on the use of a Centralized Fault Display System, CFDS. Levels of maintenance are easily identified for line stop or hangar operations, such as line replaceable unit removal or troubleshooting. The CFDS incorporates the Centralized Fault Display Interface Unit, CFDIU, which is the interface between the aircraft system's built-in test equipment, or BITE, and the MCDU. This provides maintenance personnel with a central means to display, interrogate, and test the status of the various systems. The CFDS increases efficiency, improves dispatch reliability, and reduces maintenance costs. An optional Aircraft Integrated Data System, AIDS, provides additional functions on aircraft performances, engines, and APU monitoring. And reports can also be sent in advance to the base through the ACARS, Aircraft Communication Addressing and Reporting System. Airbus has been pleased to welcome you on board and hopes to see you again soon on one of our family members.